Hello friends, welcome to EC Academy. Today we are going to study a very important topic in VLSI design, which is challenges and considerations in P-Well CMOS process design. Before we look at the challenges, let us quickly understand what is this process. See, inside our mobile phone and laptop, we have microchips. These chips are made up of tiny electronic switches called as transistors. Mainly, we use two types of transistors, nMOS and pMOS. The P-Well CMOS process is simply a practical method that is used to integrate or join both these nMOS and pMOS transistors together on the exact same chip. But bringing them together or combining this nMOS and CMOS is not always easy. It creates some hurdles and challenges. Now, let us understand the four main challenges one by one. The very first challenge is threshold voltage control. What is a threshold voltage? The threshold voltage is the minimum electrical push required to turn our transistor switch on. So to switch on the transistor, we require a minimum electrical voltage, which is known as the threshold voltage. In P-Well process, to get this perfect push, we mix some chemical impurity into the P-Well area. This mixing is called as doping. The challenge here is that we must carefully optimize or adjust this P-Well doping concentration to achieve the exact desired threshold voltage. If the doping is little bit more or a little bit less, our switch will not work at the right time and it will create problem. So setting up the threshold voltage is very important by using proper doping concentration. Now let us understand the second point, which is parasitic capacitor. In our chip, the N transistor placed inside P-Well faces a problem which is unwanted electrical weight known as higher source and drain capacitance. So, the N transistor which is placed inside P-Well has higher source and drain capacitance. Because of this extra parasitic capacitance, the switching speed of our transistor is negatively affected. Due to this, they take more time to turn on and turn off the transistor. Now let us understand the third point, which is very important. It is called as latch-up prevention. Latch-up is a very bad condition inside the microchip that can cause complete circuit failure. We definitely do not want our chip to fail. So, preventing the transistor from latch-up is very important. To prevent this dangerous latch-up, we have to provide proper well connections and substrate contacts. So these contacts which we connect are similar to safety earthing wires in your house that keep circuit safe and stable. Finally, let us look at the fourth challenge, which is area considerations. Today, everyone wants a small phone or a thin laptop. To make them small, we need to pack millions of transistors very close together. This packing is known as integration density. But there is a problem with P-Well process. We cannot put P-type and N-type transistor too closely. They require some safe spacing between them. Because of this required spacing, our total chip area increases. When the area increases, it directly affects our integration density, which means we cannot pack as many transistors into a small space that is required. So let us quickly revise the key points which we have learned today. While the P-Well process is the process to put nMOS and pMOS together, it comes with four main considerations or challenges. The threshold voltage control, we must optimize the doping to get the right voltage. Parasitic capacitance, extra capacitance slows down our switching speed. Latch-up prevention, we must make proper contacts to prevent circuit failure. Area considerations, the transistor need spacing which increases chip area and lowers the density. These are some of the challenges and considerations in P-Well CMOS process design. Hope you have understood the topic. Thank you.